Okay, Geometry, Chapter 11, Section 3, we're talking about area of polygons. Could be triangles, quadrilaterals, could be pentagons, hexagons, any of that type of thing. So just a couple of, uh, of new things. If I were to have, let's say, a hexagon, and I got this right here, and so I can draw uh, triangles, and actually let's put a center there first. Let's see, I've got a center right here. I could draw triangles and cut this into sectors, kind of like we did with circles. And obviously if this is a hexagon, it's going to have 6 different sectors. Now, in a circle, the distance from the center to the outside is going to be the radius. However, in a hexagon, something like this, let's say I draw that right there, distance to the outside, we're going to create a couple of things. We're going to create a 90-degree angle, and that will also bisect those. It will also bisect this one angle, so those two angles will be congruent. That'll be important here in just a bit, and I'm going to go ahead and color this distance in with blue, and that is what's called the apothem. Now, some will say apothem, potato, potato, it's not a huge deal, but the apothem is a distance from the center to the outside of the shape. And so it does a couple of different things. And so now let's look at actually finding some area. Let's start with rhombuses and kites. So, yeah, we can stay in blue. So I'll go with a rhombus and a kite. These are actually, I'm just going to go with formulas on these because they will give you this information. And so the area of a rhombus and a kite, what we're going to do is we're going to multiply the diagonals together, and then take half of it. So it's going to be 1/2. Where'd my color pen go? It's going to be 1/2 of diagonal 1 times diagonal 2. And so if we were to get a kite, let's see if we have a kite up here. I don't think we do, but I think we have a rhombus. And so if we were to get a rhombus like this, let's make it like that, then here are my diagonals. So you could label either one of them 1, and then just label the other one 2. So since I drew this one first, I'm going to call that D1, and then that's D2. And if I have those lengths, I will multiply them together and take half of it, and that's going to give me the area of a rhombus or a kite. And so now let's go a little bit more difficult. Let's find the area of a regular, let's just do a pentagon. So take that there, and a regular pentagon means all of the sides are going to be the same, and all of the angles are going to be the same. So let's say that I have, well, let's start with this. Let's start with the actual area of a polygon. There is a formula, and the area is 1/2. Get that down. The area is 1/2. Now I'm going to go with a little a here, and the little a, that's the apothem, and then P is going to be the perimeter. So let's say that I have my center here, which means this is going to be my apothem, and then I'm going to form a right triangle. Some of you are probably a step ahead of me and going, hey, Mr. Renault, I'll bet if you form a right triangle, we might use some a squared plus b squared equals c squared. Well, we'll see what happens. So the apothem is going to be 6.5 or 6.5. And then this distance right here is going to be 8. And we'll call that inches. Over here, inches. And so what I need to do is I need to find this distance. I don't want to use blue because I used blue as the apothem in the last example. I need to find this distance here. And then I'm going to double it. And then I'm going to multiply it times 5 because all of those are equal. So to do that, yes, we're going to use a squared plus b squared equals c squared. So that gives me a squared plus 6.5 squared equals, I'm going to go ahead and square that hypotenuse. That's going to give me 64. And so let me search for my calculator. There it is. That's going to give me 6.5 quantity squared. That is 42.25. And so I'm going to subtract 42.25 from 64. And that's going to give me 21.75. And so then I'm going to take the square root of 21.75. And that's going to give me approximately 4.7. So again, that is this distance right here, which means each side is going to be 9.4. So the sides are 9.4. Because I have a pentagon, I'm going to multiply that by 5 to get me the perimeter. And that's going to be 9.4 times 5 gives me 47. So I've got 1/2 of my apothem, which was 6.5, times my perimeter, which was 47. So I've got 47 in my calculator still, so I'm going to multiply it times 6.5, and then I'm going to divide by 2. And that gives me an area of approximately 152. I don't like that 1. 0.8 inches squared. So 152.8 inches squared. So that is chapter 11, section 2. That is area of polygons.